Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, we're back after a rare week off and we're raring to go. And we think we've got a good topic for you today. It's one that was requested by a customer, Corey Claybaugh. I hope I'm pronouncing Corey's name properly. He called in and was looking for a little bit of guidance, and we ended up with this topic. Integrate IO-Link RFID with Horner OCS. So Corey was looking to add RFID technology to his application. He called to talk to our tech support folks. And because I always love new technology, especially technology that's new to me, I raised my hand and said, hey, let's take a look at this RFID equipment. Let's get an interface in over IO-Link and let's make a video. So that's what we're doing today. Now, before I dive into today's topic, I will remind you that if you're watching live, give us your comments and questions in the chat section. If you're watching on replay, like a lot of you do, give us those comments and questions in the comment section. All right, so let's take a look at how we're breaking down today's topic. Okay, we're going to start by answering the question, what is RFID? We're going to talk about different applications for the technology. Because we're going to be interfacing RFID, an RFID reader, with the Horner OCS over IO-Link, then we need to do a quick review of that technology as well. We've got a test application to show off, and of course, we'll have plenty of demonstrations throughout. All right, here we go. Okay, so what is RFID? Well, RFID stands for Radio Frequency Identification, and its formal definition is a real mouthful. So it's a form of wireless communications that uses electromagnetic coupling in the radio frequency portion of the electromagnetic spectrum. Say that 3 times fast. So effectively, it's a wireless system that uses magnetics, really. And it's typically used to uniquely identify an object or person or animal. It just has uses all over the place. Now, the components of an RFID system, the primary components would be an antenna, a transceiver, and a transponder. And the transponder part we typically call a tag. And then very often the antenna and the transceiver portion is combined into a single component, and that's called a reader. Now, as we take a look at more detail at the transponders, which is the tags as we like to call them, note that there's a couple different types of tags. There are active tags, the tags that supply its own power, typically with a battery, and those that are passive. They get their power by being excited wirelessly by the antenna component. Now, one way you can take a look at RFID tags is that they're a specialized memory chip with a low capacity. So we're not talking megabytes or gigabytes. We're talking either kilobytes or just plain bytes. So it's a relatively low amount of memory, but there's a lot of valuable information that can be stored in that small amount of space. Now, applications for RFID are endless. So one example might be an RFID tag that's attached to an object like a shipping container, for instance. So over the course of its travels, the shipping container can come into contact, or close contact at least, into range of a RFID reader, where the RFID reader can, read the information from the tag, whether it's just an identifier, maybe whether it has some content to do with the contents of the shipping container. And the RFID reader could also be writing to the tag, with location information, updates, all those sorts of things. So really, it's pretty much an endless list of applications, certainly a lot more than just shipping containers. Now, the RFID readers typically need to be controlled either by a PLC, which is what we'll be doing today with the Horner OCS, or with a computer. And there are a variety of ways to interface an RFID reader with a PLC, and IO-Link is the method we're going to use today. Okay, now, in addition to what I talked about with shipping containers, there's literally an endless number of applications for RFID, from asset management to material handling and inventory, product tracking, security credentials. I've even heard of casinos embedding RFID tag information in poker chips to prevent theft. So literally just tons and tons of applications. Now, because we're interfacing our RFID reader over IO-Link, then we need to take a quick review at the IO-Link technology. So what is IO-Link all about? Well, it is designed to improve the level of integration between PLCs and sensors, actuators, and smart devices in general and automation systems. Now, IO-Link is not a field bus, okay, although it's often used alongside a field bus, and it features point-to-point communications as opposed to the multi-drop which so many field buses support. Now, there are plenty of advantages to IO-Link. One advantage is that IO-Link devices are very often highly configurable in the field, preventing you from having to order special factory options. A lot of the time, you can just go ahead and make the modifications in the field yourself by adjusting the parameters on the IO-Link device with IO-Link software. And we'll show you how to do that a little bit later today as well. And another advantage of IO-Link is that the masters can actually store the configuration for the devices, the smart devices that are connected to them. So if you ever have to replace one of those IO-Link smart devices, the master can reprogram them automatically to minimize downtime. So when we're talking about IO-Link and RFID readers, one of the advantages or one of the characteristics that we're taking advantage of is the fact that IO-Link offers a standardized interface for interfacing smart devices like the RFID reader with the PLC. And that interface looks like, effectively, 16 words of process inputs and 16 words of process outputs. And all the work really in the application is done through that particular interface. So as we read data from the tags and as we read status from the reader, that's all coming in through process inputs. As we're sending commands to the reader to read or to write tags, then that is all handled through process output. So really, that's where all the work is done in the application today, beyond just getting the initial configuration done, and that is manipulating those process inputs and process outputs. Okay, now the components you're going to need at runtime for a system like this, of course, you're going to need a PLC, and in our case, any modern Horner OCS, because the communication is going to be done actually via Modbus, and just about any modern OCS supports Modbus. You'll need an IO-Link master, and Horner offers either 2-channel or 4-channel versions. We don't manufacture those. We work closely with Banner Engineering, who's the manufacturer, but you can purchase those either directly from Horner or from Banner, whatever works for you. You'll also need a cable that interconnects the IO-Link master and the Horner OCS, and it looks a little bit like a Y cable because it also is used to supply DC power to the IO-Link devices as well. All right, so that part number's up there on the screen, or you can build your own. And then also, you're going to need, of course, an RFID reader that's compatible with IO-Link. Now today, we're going to be using the one that Corey selected, and that is an RFID reader from Siemens. And then to interconnect everything, you're probably going to need a series of M12 cord sets because IO-Link has been designed really around using standard sensor actuator type cabling to interconnect everything. Okay, now in addition, there's some configuration that has to be done, and that will require some free software from Banner. Okay, it will also require an IO-Link configuration adapter, all right, that is shown there on the screen. And then at some point, you're going to need to download what's called an IODD file, and that typically will come from the manufacturer of the smart device that you're interfacing with. In this case, we downloaded an IODD file from the Siemens website for their RFID reader. Okay, so let's go ahead and get started. The first step is we're going to show you how to configure the RFID reader over IO-Link. Okay, let's take a look at the IO-Link side of the setup here. Now, first of all, on the bench, I have my IO-Link master connected to the configuration cable. So it's not connected to the OCS yet. The IO-Link master is connected to the configuration cable, and on the other side of the IO-Link master, of course, is the RFID reader that we're looking to configure. All right, so I'm going to go ahead and hit connect here. Remember, the configuration cable is connected via USB to my computer. So that's the COM port that it found it at. So I'll hit the connect button. Okay, and it's scanning the devices that are connected to the master. and it's got information here on the master in the first tab, and in the second tab, it has the information for the device that it found on port 1, and there was no device found on port 2. That's why that's missing. So if we take a look at what's found on port 1, that's the part number for the Siemens device that we're interfacing with here. This is the generic information for it. It gives you information like device ID, process data lengths, all those sorts of things. And then you can take a look at process data. All right, so you can get a preview of what the process data looks like. If I were to put a tag on here, now I'm not executing any kind of a read function or anything, but I can at least see the presence of that tag on the reader. So that kind of verifies things are communicating like we'd expect. All right, so that's the process data. And then I can go to the parameters area and hit the read parameters button. Now, for whatever reason, we had some trouble reading all the parameters out of the Siemens device. I think there was a bit of a compatibility issue with the Banner software, but the reality is it didn't really hurt us any because there was only 1 byte of parameter data that I needed to change so that the Siemens device would work in my application. And that was, I needed to change the mode of the reader into a mode where it would read the tags and not just read the UUID. So that was 1 parameter I needed to access and change, and so I could do it here from the generic tab. So I can type in the address of the parameter, which in my case was 40 hex or 64 decimal. I can press the read button, and then it comes back with the 8 bytes for this parameter. Now, the specific byte that I needed to change was this second one here. By default, that one has a value of 4, which means it's in scan UID mode, and I needed it to have a value of 8 for scan user data. So that's where it's at now. It's got a value of 8 there. So basically what I did was I just typed in the values that I needed, okay, like this, 02, 08, 02, just copied them straight across. Of course, changing the one that I needed changing. It was 4 when I first did the read on the device. Press the write, and it writes this data. I read it back just to verify everything changed, and we were good to go. So that was a step I did have to take on this particular reader to change that 1 parameter. Okay, now once I had done that, then really that was all the configuration that was required in my example. Now, in other videos, I've shown you how you can set up the master, the IO-Link master, so that it will automatically reprogram the device that's connected to it if you ever have to swap that out. So I would encourage you to go back and watch one of those other videos. It's about a 2 or 3 step process, not that difficult, but I'll skip that for today's video. So really, that's all the configuration that I had to do for the RFID reader today. Okay, so the configuration on the IO-Link side isn't bad at all. So let's get into the meat and potatoes of the application, starting with just a quick review of the components that we're using for today's system. So we're starting with an XL4 Prime OCS, so that's a 4-inch model, but you could use really any Horner OCS. We're using, as we mentioned earlier, a Siemens RFID reader, an RF260R. We're also using some Siemens tags that have about 112 bytes of capacity each, read-write capacity. And then we're using a 2-channel Banner IO-Link master. If you buy it from Horner, we've got the part number there on the screen. And then, of course, that is interfacing with the XL4 Prime over Modbus protocol. Okay, now, again, all the work in the application really is in manipulating that process data, the process input data, and there's 16 words of that coming from the reader through the IO-Link master into the Horner OCS, and then there's 16 bytes going the other direction from the Horner OCS through the master to the RFID reader. So that's really where all the work is done. So for the input side of things, we are monitoring status. We are monitoring or taking a look at data bytes. Those are the numbered bytes you see there on the screen. And that's where the read data will ultimately be located for us to copy into our program into other variables. And on the process data output side of things, That's where we manipulate the data to send commands to read tags or write tags. That's where we specify where in the memory of the tag we want to either read data or write data to. Okay. Now let's take a look at the process of executing a read. Okay, so to execute a read, we basically start by writing to the right portion in the process output data, which specifies the memory location where we want to read from. Because remember, a typical tag is going to maybe have a couple hundred bytes of data that can be read, and you need to specify where you want to read from. So in this case, the high address and the low address is what you fill in order to specify that address that's to be read. And then you follow that up by putting a 2 in the command byte, which tells the reader that you want to perform a read. After that's done, then effectively the application is waiting for the ready bit to turn on. The ready bit is the high bit of the status byte. If that turns on, you know the reader has completed the task. It's read the data, and at that point you can go ahead and copy the data that was read from the data area in the process input section over to your variables. Now, if you did have a problem, maybe you tried to read from an illegal address or something, then the error bit could turn on, and that error bit happens to be the next to last bit of that status byte that you are monitoring. Okay, so that is how we perform a read. Now, to perform a write, it's very similar, but just the opposite, if you will. So we start by specifying the memory address that we want to write to. We fill in all the data that is to be written through those 28 data bytes that are part of the process output data section. And then we write a 1 to the command byte, telling the reader we want to perform the write function. And then we sit back again and monitor status to see if it went through successfully with ready turning on, or if it failed by the error bit turning on. So that's the process of writing. One more thing before we show you the Cscape configuration and the bench demos, and that is, let's talk a little bit about how memory is accessed in the tag. So remember, these tags are basically memory chips with different sizes of memory available to be read or written from. The Siemens tags we're using in today's demonstration have about 112 bytes of read-write memory available, and these happen to be addressed from 0 to 6F in hex, which I believe is 0 to 111 in decimal, and those are the values we'll need to be setting for our addresses that we want to read and write, somewhere in that range. And when we determine the address we want to read or write to or from, then we need to fill that information in, the 2 bytes that are there for the high address and the low address. So that's basically a little bit more extra information about how you access memory from the tag. Okay, so now we're going to come to the last portion of our demonstration. We're going to go through Cscape. We're going to go through, on the bench, reading tag data and writing tag data. Okay, let's take a look at the setup that's required in Cscape along with the programming. So from a setup standpoint, it's really a matter of hardware configuration and serial port configuration. Remember, the interface between the IO-Link master and the OCS is via Modbus, so we need to assign Modbus protocol as a master to MJ2, that's our RS-485 port, and then we have 3 levels of configuration. Pretty simple stuff. On the network level, this is where we set our parameters. These are the default configuration, baud rates, etc. for the IO-Link master. Plenty fast enough for this application. We select Modbus RTU, set reasonable values for retries, timeouts, and reacquire. We set our update interval to be as fast as possible, which is a 0. And then we definitely want to assign a variable for Modbus master status. So that's 4 words we can monitor that tell us the number of milliseconds of our communications, round trip, if you will, for reading and writing all the parameters, as well as the number of good messages, bad messages, and corrupt messages that we have. So that's important troubleshooting information, so don't forget to assign that. Okay, and then under devices, that's where, remember, it's only the IO-Link master that needs to be listed here because that's what we're communicating with over Modbus. Its default Modbus ID is a 1, 5-digit Addressing for Modicon is perfectly fine for the Modbus protocol. So pretty much everything is all defaults here. And then we also assigned a 2-word status variable for status of the slave that we can monitor. And then finally, the third level is our scan list. So we've got 17 words that we're going to be reading. Okay. And the Modbus address is dependent on the port number of the IO-Link master where the device is connected. So this is, remember, we're talking to, ultimately, the data is being routed to the RFID reader, and it's connected to port 1. So the data from the reader is coming into Modbus address 41001. And we are assigning it there to a word array that's 17 words long, and it's a polled read. And then data going the other direction is addressed for Modbus 41051. That's the write data. Okay, and that's a polled read/write. Okay, and that also is assigned to a word array variable as well. Okay, so that's where the data is going out and coming back in. All right, the process data, if you will. Now you may be wondering, I thought there was 16 words for the RFID reader, both in and out. Why is our length 17? That's because there's an extra word tacked on at the beginning for information regarding the actual master itself, okay, and how communications is going between the master and the RFID reader. Okay, so some additional diagnostic information there. Okay, all right, so that's the configuration, the hardware configuration, if you will, the Modbus configuration between the OCS and the reader. Now it's the rest of the application is just programming for manipulating those 16 input words and 16 output words to do what we want to do. So one of the things we want to do is read tags. So the process of reading tags is going to involve setting the address in the tag reader for the data to be read. Okay, and that is in this case 80 decimal. Okay, which I believe is 50 hex. That's the address that I'm reading and writing in this example application. And then we're going to stuff a read command in the command bit, and that's a value of 2. I've got another bit that I turn on here that says, hey, the read is active, so I'm waiting for the tag to come into the tag reader. And then once that ready bit turns on from the tag reader, okay, then I'm going to copy the data that was read from the tag that's residing in some of those 28 other data bytes and copying those into the variables I want to copy them to. Now I happen to be copying them into some byte array variables, okay, but I've also mapped those byte array variables into an area of OCS memory where I also have some double integer variables mapped to the same locations. So even though this data is being copied over to a byte array, in both cases, through a clever bit of memory mapping, it's also ending up in a double integer variable, okay? And the reason I'm doing this is because I'm moving bytes, and so both the input and output variables have to be bytes, okay? Ultimately, I want the data to be residing in a double integer, so that's why I'm doing the clever memory mapping trick. Okay, so that's the read functionality. Write is very similar, okay? And that is, I set the memory address that I'm going to write. I get the up to 28 bytes of data that is going to be written. I get that all copied over. And then I set the command instruction, which in the command byte for a write is a value of 1. Okay, and then I'm going to sit there and wait for the ready bit to turn on, knowing that my write is complete. Okay, so that is the logic required to do a write. Now, one other little thing I want to show you, and that is this. I've mentioned a couple times that we need to look for the ready bit to turn on. What is the ready bit? Well, the ready bit is the top bit of the byte number 1 coming back from the RFID reader. When I say byte number 1, it's actually the second byte. Byte 0 is the first byte, byte 1 is the second byte. So the second byte coming back, the top bit of that is my ready bit, and the next to last bit is the error bit. So I've replicated those here so I can easily use them throughout my program. Okay, so that is the Cscape configuration and programming required for our application. Okay, let's demonstrate reading tags on the bench. All right, so I've got a read push button here, which I could just as easily trigger inside my logic program. Doesn't have to be done from the screen. But what that is doing is causing my logic to specify the address from the next tag that comes across that I want to read, as well as putting a 2 in the command byte, again, instructing the reader that we want to perform a read. And again, next time my tag comes across, okay, I get the data there, my ready bit turned on. I can then store that data away, clear the data away, and get ready for the next tag. Don't want to forget to arm it. There we go. Repeat the process. Store the data away, clear it, rearm the reader, and away we go. So very straightforward to read tags using the interface. Okay, now let's perform a write. So I'm starting here with this tag. Let's verify there's nothing on it, or at least not the data that we want to be on it. I'll perform a read here. And those two particular data fields or memory locations are at 0. They're not necessarily set the way we want them. So now let's go to our write screen. And this is the data that I want to write to this tag. So those are in the appropriate memory locations in the logic code. And we're going to write a 1 or a write command in the command byte. So let me hit the write bit here to arm that. Okay, ready? All right. Put it on a second time. All right. And now let's go back and verify the data with a read. There we go. Okay, that's our program for today. This is where I remind you that we're here every Tuesday at 2 o'clock. Well, at least most Tuesdays, this month being a little bit of an exception. But if you watch us live, we're always available to answer your questions live from the chat section. If you watch on replay, we'll get those questions answered from the comment section instead. Okay, so don't forget to sign up for OCS training this year. We've got a class coming up in a couple weeks for basic training. Plenty of other classes available as well. Sign up on our website. There's lots of ways of interacting with Horner online, whether it's via LinkedIn or our YouTube channel or on our website at hornerautomation.com. Okay, so next week, we're launching a new product. Pretty exciting, or at least it's a new revision of a product, and that is our new Wi-Fi adapter Gen 2 from Horner Automation. Now, for those of you who are interested in having a Wi-Fi connection with your controller, this will allow pretty much any Horner OCS with a USB-A port to sit on Wi-Fi directly from this adapter. That includes the entire Prime series, for instance. Now, if you haven't done so already, don't hesitate to subscribe to our channel. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week, let's all get out there and do us some good.